positive in how many quadrants and negative in how many quadrants? Here's a question for you. How many quadrants is all 3 trig ratios negative? Negative. None of them. It only happens that all 3 are positive in one, but none of them are all 3 negative. Make sense to you? Okay, an easy way to remember which function is positive is using the cast rule, but some people keep on putting the C in the wrong spot. I don't know why this plus sign is so small. C-A-S-T, as otherwise known as all students take calculus, and then it starts in the right quadrant, right? All means all the trig ratios are positive. S means sine is the only one that's positive. Tan's the only one that's positive. Cosine is the only one that's positive. Okay, let's recall. This is everything put together. Determine the angle given the reference angle. So if my reference angle is here, remember theta r? How would I determine what theta is? It's just whatever it is, right? They equal each other. What about over here, if I have the reference angle? How would I determine what that angle is? Who knows? Well, it's 180 minus that, right? 180 degrees minus is your theta. Okay, how about if theta is in the third quadrant? How would I determine what that angle is? Yeah? Yes. 180 plus the reference angle equals your related angle. And last but not least, how would I figure out the related angle in the fourth quadrant, meaning all the way around? Anybody? 360 minus the reference angle gives me my related angle. Okay, so this is all review. Let's keep on going. So we're going to solve for theta. Do you remember back in the day, I don't know, grade 8, grade 9, you had an equation that looked like this. 2x plus 1 equals 0. Solve for x. How would you do it? You would subtract 1, and I'm not going to make you go back in grade 8 where you show each step. You'd subtract 1 to both sides. What would you get? 2x equals negative 1. That's what I mean. I'm not showing all my steps here. Then what would I do? Divide by 2. So I get x equals negative 1/2. Everybody understand that? We're doing the same thing over here. We are going to isolate our trig ratio. So pretend that's like a big X. We want to get that big X, or sine theta, isolated by itself. So how would we do that? We would move the 1 over, then divide by 2. If you want, I can show my steps. 2 sine theta equals negative 1. I move the 1 over by subtracting 1. Then I divide it by 2, so then I get sine theta equals negative 1/2. Everybody good with that? Okay, I am trying to solve what theta is, though. Okay? So you can use your hand, or you have this memorized. I don't really care how you do it. You just got to know. Look at your hand. Where would I have the 1/2? That would be when I put my 30 down. My sine is 1/2. That's that one finger. So my reference angle is 30 degrees. That's not my answer. That's my reference angle. So now I know which family to look for. And then after that, sine is negative here. Do you see that? Which two quadrants is sine negative? 3 and 4. So who can tell me? So I'm going to put 3 and 4. Who can tell me which related angles are in 3, 4 in reference to a 30-degree reference angle? Ness? 210 and 330 degrees. Very good. Okay, does everybody see how I got that? We're not using a calculator here. By the way, say I wanted to use my calculator. Would anybody know how I would get from sine theta equals negative 1/2 to this? You would inverse sine both sides, yeah? You did this in your right angle trig when you're solving for an angle. Ring a bell? Okay. So let's move on here. Oh, that was my only example? Yeah, I guess so. Okay, this one is not in an exact value. So we're going to take out our calculator right now. Okay? Make sure your calculator mode is in degrees. Okay, so in order to get from cos theta to theta, what we do is we undo the cosine function. How do we undo a cosine function? We inverse cos both sides. I'm going to show my step on this side, but I'm going to inverse cos both sides. Does everybody know the inverse function is to the power -1? A lot of people refer to it as the second function cos, but that's actually the incorrect. That's just calculator jargon because it's the second key of your calculator. It's actually inverse cos. And when you inverse cosine, you actually get the reference angle. Okay? So inverse cos 0.3, what do you get? Let's round to the nearest, oh, it says to the nearest unit there. So let's inverse cos 0.3. Yeah, so that would be 73 degrees. Now, when you do one whole rotation from 0 degrees to 360 degrees, cos is positive 2 spots. Yes? So my reference angle is just going to tell me how to get the 2 spots. So, where's the first spot? There's cos positive 1 and 4, right? So what's the angle in quadrant 1? 73 degrees. Because the angle is the reference angle in the first quadrant. And what about the fourth quadrant? 287. Very good. So what do you think about that? It's not that bad? Just so you guys know, tomorrow we're going to have kind of like, not a rest day, but I'm not going to teach a new lesson. I'm going to like just hammer you with the exact values and solving tomorrow, okay? Huh? Get hammered with math, that's right. Okay, how would we get this one now? Inverse cos both sides. Again, we get the reference angle. Okay. So make sure you put the negative in. For this one, you will use a calculator. I'll tell you when you don't use a calculator. So did you get 110 degrees? Now, is that your reference angle, 110 degrees? No. You got what? You probably didn't put the negative in. You should get 110 degrees. So here's a little glitch in our thing. Sometimes it only happens for cosine when the cosine trig ratio is negative. It gives you that second quadrant answer, 110 degrees. So what in fact is my reference angle? 70 degrees. So there's a glitch. There's a little bit of a glitch. So, yes. So Jessica inadvertently figured out if you don't put the sign in, she actually gets the reference angle 70 degrees. So what I want you to do from now on is don't worry about this negative sign when you do it. Then you will automatically get the reference angle because the calculator will automatically give you this first quadrant answer. Now, the answer isn't the first quadrant necessarily, but it's the reference angle. So remember this. If you put it exactly the way it's written with a negative, you may in fact get an angle that's not the reference angle. So then if you add 180 or subtract 180 to that, you will get the wrong answer. Okay? It's way far better, more efficient to ignore the sign when you use your calculator. And even when you use your hand, You don't worry about the negative when you use your hand, right? So why would you worry about it here? So put it in as positive. You'll get 70 degrees. And then you just need to figure out where is cosine negative, which two quadrants? Well, this one and this one. So who can tell me what the answer is here? 110 and 250. Very good. Any questions about that one? Okay. Is root 2 for 10 on the unit circle? Think about this. What's the only values for tan that are on the unit circle? No. The values for tan theta. 1 or negative 1. 0 or undefined. And
1.
Root 3 or 1 over root 3 plus or minus, right? Okay, so this is not an exact value. Again, ignore the negative. Inverse tan root 2. This is where you really have to know your calculator. 55. So again, we write theta reference is 55. Try again. You got to ask yourself, where is the two quadrants that tan is negative? Do you see it's a negative sign there? The ratio is negative. So what two quadrants is that going to be in? I'm sorry? 2 and 4. Very good. So 2 and 4, I'll just write. So now, can you find the related angles with 55 in quadrant 2 and quadrant 4? Who can tell me the second quadrant one? Anybody? 125, very good. And 4? 305. I didn't need a calculator for that one. Okay, how are we feeling? Is it kind of all coming together? That's the nice thing about pre-cal is that every day builds, and then all of a sudden it just kind of starts forming better, right? Okay. Uh-oh. Uh-oh. What do we do here? What happens if this said 3x minus 5 equals 7x minus 6? What would you do there? Yeah, the ones without the x's, you move to one side. The ones with the x's, you move to the other side. It's the same thing here, except it has tan thetas. So keep them together. I'm going to move this over to there. So how am I going to do that? Subtract. What's 3 subtract 7? Minus 4. So I'm going to have minus 4 tan thetas. And if I'm going to move this minus 5 over to the other side, what would I get? Minus 1. Did I lose anybody there by not showing my steps? Okay. So then, what would I do after that? If this was negative 4x equals negative 1, what would I do? Divide by negative 4. So then I'd get tan theta equals what? What's negative 1 divided by negative 4? Positive 1 over 4. Yes? A negative divided by a negative is a positive? Do you see I'm not showing every step here? And if you're good with that, then I'll keep on doing this, and that's what I expect. When you're at grade 11 pre-cal, we're not going to show every step. You do have to show steps, but I don't need you to show plus 1, you know what I mean? Like, we're not in grade 9. Okay, so, is that in the unit circle? No, that's not one of the tan values. So I have to inverse both sides, inverse tan both sides. And what do we get? Yeah, we get a really small, 14 degrees, that's my reference angle again. And so, and do you see the tan ratio is positive? Yes? So where's tan positive? Not 1 and 4, 1 and 3. So theta equals, I'm sorry? Well, 14, yeah. And 3 would be 194. Very good. Okay. Do you want to solve this one? You want to solve this one? I'll give you a second. Okay, so so 4 sine theta equals 5, so sine theta equals 5 over 4. When you punch this in your calculator, you will get an error. But at some point, you're going to have this on the non-calculator part, and you have to know that something about the trig ratios. Okay, so I'm going to give you a little picture here. And you remember when I draw this reference triangle? What's the only thing we know no matter what the degree is? The radius is 1. And what's special about that side? It's the hypotenuse. And what's significant about the hypotenuse in a right triangle? It's the biggest side. It's the biggest side. So no matter what this is over here, it has to be less than 1. Does everybody agree? So now, can you think of anything that you could place here? And let's think about sine for a second. I'll put theta there. Anything you could put on the opposite side, because remember, sine is opposite divided by hypotenuse. And if my hypotenuse is 1, can you think of anything that you could put right here that I would get 5 over 4? It's impossible. Because the biggest side is 1. The only thing we could put here is fractions, right? Or decimals that are less between 0 and 1. So 1/2, 3 over 4. You could put anything in there, but if you divide by 1, you would never get 5 over 4 over it. Okay? Same with cosine. If you put anything here on the adjacent, right here, could you think of anything that you would get over 1 when you divide by 1? It's impossible. So sine theta has to be less than 1. And it could be less than or equal to 1, because you could have sine theta equal to 1. Where is sine theta equal to 1? On the unit circle. Where is sine theta equal to 1? 90 degrees. The y value is 1. That's why I have an equal sign. Same with cosine. It has to be less than or equal to 1. However, we could go into the negatives, and how far in the negatives could we go? -1. Yeah. So this is something you should know from this day on, that you can never get a trig ratio that's bigger than 1 or smaller than -1 for sine and cosine. Now think about tan now. Could that be possible for tan? Could you have a trig ratio bigger than 1 for tan? For sure, because remember, these are fractions here, and tan is opposite divided by adjacent. And if you take a fraction and divide by another fraction, if you divide by, like, say, 1/2, you're actually doubling it, right? Dividing by 1/2 means you're multiplying by 2. So you would actually get, a lot of times, tan would be a ratio bigger than 1. So what do we say here? Undefined. Actually, you know what? I regress, because we are solving. So the answer is there a solution for it? Because all these are solutions. So the value for that angle is undefined, but the solution is no solution possible. So you can say NS or no solution, because we're solving and trying to find a solution. So we would say no solution. Okay, so anytime you have a reference angle that's 0 and 90, I see a lot of people trying to use their hands for it. I wouldn't. I would use this. This coordinate is 1, 0. This coordinate is 0, 1. This coordinate is -1, 0. And this coordinate is 0, -1. Not that your hands won't work, but it's honestly, I think it's more complicated. It really is, right? So sine is either 0 or 1. Do you see 0 or negative 1? 0 or positive 1? Cos is 0, positive 1 or negative 1. Yep. And tan, remember, because tan for the 90s, you're taking y and dividing by x. We're either going to get, what's 0 divided by 1 again? 0, and what's 1 divided by 0? Undefined. Okay, so do you see only the values we'll get here? A trick for remembering trig values on the x or the y axis. Do you have a trick at this point that's going to work for you? How many people like the hands? Some people just haven't figured out that hand yet, hey? Yeah. Okay. Example 3 is without a calculator now. So let's isolate our trig ratio. What do we get? Matthew, what do we get? I'm going to isolate my trig ratio, or trig function. What do I get? Can anybody help him? Yep. Yeah, I'm going to subtract 1 to get it on the other side. Don't drop your theta. It's cos theta equals negative 1. You'll lose marks. Okay. You need to recognize that this is on the x or the y axis. I guess what I was looking over here is, what's the trick? I don't know. It's just putting the coordinates in there. That's what I think I was looking for there, which is what I wrote on the other page, but anyways. Oops. Okay, 0, negative 1. Okay, so you're supposed to recognize that having cos theta equal to negative 1 is an exact value on the unit circle. It's one of the ones that's on the x or the y axis. What is cos again? X or y? X. So where is your x value negative 1? 180, that's the only spot. So recognize the equation as a special case, yeah. Using the corresponding trig ratio, determine the value for x and or y. This is the coordinate, the x coordinate. So without a calculator, my theta is 180 degrees. There's no other spot, right? Okay. I guess I left some blanks there. Okay, without a calculator, do you guys want to do this yourselves? Yeah, do it. Okay, so sine is 0. That means if you look at your little axes, the y value is 0 in essentially 2 spots, but actually 3 angles between 0 and 360, and it also includes those, right? That's what the equal sign says. So theta equals 0 degrees, 180 degrees, and 360 degrees. So that's the one time we have 3 answers. So on the axis, you'll find that you'll have unique kind of characteristics, meaning you might get one with 3 answers, you might get one with 1 answer, you might get one with 2 answers. So, but all the other spots where you have actually reference angles, you'll get 2 spots, right? In one rotation. If I subtract 1, I get 2 tan theta equals 0. So if I divide by 2, what's 0 divided by 2? 0. Where is tan theta 0? It's actually the same exact answer as the previous one. Yeah. 0, 180, and 360 degrees. Does everybody understand why? Because I'm taking sine and I'm dividing by cosine. And the only way I get 0 as my answer is if I'm going 0 divided by something, right? And the only spot that 0 is divided by something is when sine or when my y values are 0. So maybe I'll put that here. Tan is y divided by x. So in order for this to be true, that would have to be 0. You can't have 0 on the bottom. Okay. Oh. That's it.